So in the last session we discussed resistance. So just for the recap, I told you that R is equal to rho L by A, and you know you need to be careful that whenever it is mentioned wires, identical wires or similar material.
I couldn't hear you, Islam.
Just hold on, I will reconnect it again. Maybe internet speed is not so good. Just give me 1 second. Hello? Hello? Is it okay now?
Yes, sir, yes, sir.
Right. So this was the last thing we discussed, and the example which we discussed is, let's suppose you have a wire of length L, or simply question was a wire is stretched to double of its length, right? So that means I told
Yeah.
you that the accurate way to solve that case 1 and case 2. So initially the length was L. Let's suppose area of cross section was A. Now you are saying it's doubled, so 2L, right? So since the volume has to be conserved because mass will be conserved, so let's suppose final area is AF. So I will say that initial volume is L into A, finally 2L into AF, and this will definitely give me AF is equal to L into A upon 2L. That will be A by 2. Right. So if I want to find resistance in the first case, this was rho L by A, because L and A were their corresponding dimensions. In the final case, it was rho times total length, that is 2L upon final area. What is the final area? A by 2. So from here I will get 4 times rho L by A. So we have two equations. This is equation number 1, equation number 2. You divide both the equations, right? And even you can directly relate also, because rho L by A was R. So can I say that RF is equal to 4 times R? So final the answer will be that final resistance is 4 times the initial resistance. Another answer will be percentage change in resistance. That will be always final minus initial upon initial multiplied by 100. That is 4R minus R upon R into 100. That will be 300%. Is it okay? This was the thing we
Okay.
discussed. So this is done. We'll move to the next part. Can we move on?
Yeah.
Alright, talking about the series and the parallel combination. We'll do it series and this is parallel. Right. First thing, what is the series combination? Let's suppose we have three bulbs. Resistance, you can say three bulbs in series, three fans in series. All the any electrical equipment will definitely have some sort of resistance. Let's suppose these three are connected in series, and we connect this along with a source of EMF. Let's suppose 20 volt or maybe V, for example. This one is R1, resistance 1, resistance 2, resistance 3. This is called series combination. Now how to relate, how will you decide whether it is in series or parallel, right? So if the three resistance are in series, right, there will be only one way, or you can say single way of communication, only way of one way of or path of communication. And by the word I mean communication, I means the inflow and the exit of the current, right? Communication here stands for the flow of electrons, because current is due to electrons, right? So you can see whatever the amount of current has been supplied by the battery will go like this, U and it will reach the resistance one, that is bulb 1, electric bulb 1, CFL, LED, whatever it is, right? It will pass through this, again will go through this R2, R3. So can we see that through R1, R2 and R3, whatever is the current going in R1 will be equal to the current in R2, will be equal to the current in R3, because there is only single means of communication. Are you getting what I am trying to explain?
Yes, sir.
Right? So you can also think it like, just as a tube of water, right? So if you add some source, such as tap, this is a tap source, right? Water goes like this. So there is only one tube, so the same amount of water will pass through all the three sections, right? So these are also in
Yeah.
series. Okay. So which quantity will remain same in case of resistance in series? Current will be same in all three resistance. So I have taken three resistance. You can have 5, 6, anyone, right? Will be same in all three resistances. Current will be same in all the three resistance, right? Now, so we have, I want okay, instead of this three, I want to place only one. What should I do? Right. So we can do, देखो, let us take some realistic example. This is 10 volt, right? This is 2 ohm, okay. This is 4 ohm and this one is 1 ohm. Or let us take it as 4 to 6 and make it 1, 2, 1, 3. This is 2 ohm, right? So if I ask you, what is the amount of current in each one of them? So that will be I. I is the amount of current in all the three, right? Now by Ohm's law, we discussed V is equal to IR by using this law. If I ask you,
Yeah.
what is the potential across 2 ohm? That is, this first one, R1, R2, R3. Potential across this R1. You will say that potential, that means you are asking V across 2M
Yeah.
should be current in that. What is the current? I don't know. Let's suppose I, right? Multiplied by 2,
Yeah.
right? Again, you will ask, what is the potential difference or potential drop across 1 ohm? I will say that is again formula I into 1. Potential across 2 ohm, the last one, R3, it should be I into R3, right? So there is potential drop across each and every resistance, right? So if I sum up all of them, so there were three elements in the circuit, that is three resistance. So V1, let's suppose, plus V2 plus V3, all the three. Let us assume this is, I am representing V1 and this one is V2 and the third one is V3. So if you add them up, I, this is 2I plus 1I plus 2I, that will be 5 times I, right? Is it okay? Yes.
Yeah.
Now the total potential supplied by the battery was, total potential given by the source or battery source was 10 volt, 10 volt. So can I say 5I has to be equal to 10 volt? 5I is equal to 10 volt. From here I will get I is equal to 2 ampere. How? Right? 5I is equal to 10. That means I is equal to 10 by 5. That is 2 ampere.
Okay.
Is it clear?
Yeah.
Right. Now, I'm trying to generalize it now. I'm trying to generalize it. Okay, let's suppose we don't know the value of resistance. I want to derive a formula. What I could have done? V net, that is the net potential supplied by the battery. Right. Let's draw a diagram. V net. This is your V net, and this is R1. This is R2, R3. I should have said. I should have said. I into R1 plus I into R2 plus I into R3. Right. So can I conclude that I is equal to V upon R1 plus R2 plus R3? Because I could have taken I common in all these things. So this is V upon R equivalent, right? And finally we can substitute that R equivalent is equal to R1 plus R2 plus R3. What is the meaning of the equivalent? It means that, instead of this three, we could have placed only one resistor whose value is R1 plus R2 plus R3. I will show you an example. So if you have noted, we can move on.
Okay. I'll notice.
Be fast.
That's it.
Done? Okay. Let me finish the parallel also, then we will move to some question. So point to be kept in mind is that the current is same in all the three resistor if they are in series. Right. Next is the case of parallel combination. Now let's suppose this is three resistance, and I'm saying that three resistance means three bulbs or three any electrical device are connected like this. This is your battery. This is your three elements R1, R2, R3. Now in parallel circuits, in parallel, potential difference across all the parallel resistors are equal. Resistor is same. Potential difference across, let's suppose two resistors are in parallel. That means potential difference across them or potential drop across them will be equal. Right. So take a realistic example now. I'm giving you one realistic example. Let's suppose this is the case. 20 volt, 3 ohm, 2 ohm. Right. Now, what is the meaning of the parallel? How will you identify these two are in parallel? For resistance to be in parallel, their endpoints have to be connected at the same point. Their endpoints should meet, or you can say should have the same potential. Should have same potential.
So where are the endpoints, sir?
This one. Let's suppose, this is 3 ohm, right? So endpoint is this one. At this point, both of them are meeting, right? So I will say that, right? And one another endpoint is like this, right? So in series, only one endpoint was meeting each other, right? There was only one endpoint who were common, but in parallel, both the endpoints will be common. This is parallel. Okay. Now, so this is how we identify which one is series, which one is parallel. Now, if I ask you, right, I told you already that parallel potential difference is same. Whenever I say potential difference word, you should keep in mind V that is equal to I times R. So potential difference across any resistance is current in it multiplied by its resistance value. Right. Now let's suppose the current I started from the battery that has been supplied by the battery. It will go I up till this point. Now on reaching here, it has two branches. So if 10 liter of water comes here and there is two pipe, so of course in both of them few water will go. So I can say this is I1, let's suppose this is I2, right? I don't know what is the value of I1 and what is the value of I2, but I am sure that there are two branches which are going to be coming out of that the original value of the current. Okay. Now I am very sure that potential difference across 3 ohm is equal to potential difference across 2 ohm. Why? Because they are in parallel, right? I am very sure about this. Now if I ask you what is the value of potential across this 3 ohm, so as soon as I asked potential difference, the term clicked in your mind is I into R. What is the current in this? That is I1. What is the resistance? 3 should be equal to I2 into 2. From here, I got relation that
Yeah.
I1 should be equal to 2I2 upon 3. Equation number 1. Now, I also know that the original value of current should be sum of I1 plus I2. Is it okay?
Okay.
So can I say, because I have already found I1 in terms of I2, I can write 2 by 3 I2 plus I2, that is, 5 I2 by 3, that is the value of total current supplied by the battery, right? Now this is another equation you can say. Okay, we have this data also in this, okay, any doubt?
Um,
No.
sir, how do you get 5 I2 by 3, sir?
If you apply it, this is sum 2 by 3 I2 plus I2. I took I2 common, 2 by 3 plus 1, I2 2 plus 3 upon 3. Do you know how to add fractions?
Yeah, yeah, yeah.
This is right. Is it
Oh,
okay now? You got it, I hope.
okay, sir. But how do you multiply it, sir? It's given I2 plus I2 only.
Where it is I2 plus I2. I have not multiplied it. This is the value which I need to solve. I have taken I2 common. I2 common. This is in brackets. Out of this I have taken 2 by 3. Out of this I have taken 1. This is same as if I write 2 plus
Sir,
2x. What will you do? You can take 2 common, 1 plus x.
yeah.
This is the same thing I have done. Is it okay?
Okay.
Sure?
Yeah.
Okay. Now, let's come to the basic. The steps are important. Keep in mind, the steps are important. This will help you in numericals. Let's come back to the original part of the derivation, you know, which will give us the formula. Right. Let's take it for the 2 only because it's bulky. This is V, this is R1, this is R2. Now, okay. Now, देखो, one thing I can say that this is I1, this is I2. So that means the net current I is equal to I1 plus I2. Right. So can I conclude that the net current supplied by the battery should be equal to net voltage of the battery upon net resistance, which I say equivalent net resistance, because I am trying to find one value of resistance which should be kept instead of this two, right? And what is the value which I am bothered about that one, right? So V upon R equivalent is the net value of current, right? Current is still same, right? Should be equal to what is R1, what is I1? Can I say potential across this upon R1 plus this one? Why I have taken V in both of them? Because you can again see, देखो, one thing again, a concept, keep in mind, this is 10 ohm. For example, I will come back to this point. you know if I write here 20 volt, this directly means potential difference across this 10 ohm is 20 volt, because the end points of the resistance are directly connected to this. There is nothing between this point A and the battery, right? Is it okay?
Yeah.
But if I change the situation, like this is 10 ohm, and if I placed, let's suppose, one 2 ohm resistance more in the circuit, now I cannot say that the potential across this 10 ohm is 20. No, this is wrong now, because the endpoints is not directly connected to this battery. Now in between we have 2 ohm. Is it okay?
Okay.
Right, this is important. So now in this diagram, you can see that the end point of the resistance is directly connected to the battery of both of them, in fact, right? So I can conclude that potential across this R1 as well as R2 is V only. So I have written V. Now you can take V common. So V will be cancelled. So it will be 1 upon R equivalent is equal to 1
Sir, your
upon R.
voice keep breaking, sir.
Y upon? Oh, the voice is breaking. Okay, okay, I got it, got it. Maybe some internet.
Yes, sir, I couldn't hear you, sir.
Just hold on for a minute. I will reconnect it. Uh, yes. Now it will be fine, I hope.
Yeah.
Right. So, after this equations, I cancel out the v because v was common in all the three terms, and finally I got this formula: 1 by r equivalent is equal to 1 by r1.
So again, what?
Hello. Hello.
Hello.
Yeah, I'm there. In general, the time to gist up whatever we have done for resistance in series or for series combination, right? R equivalent is R1 plus R2 plus R3 plus dot dot. It means that whatever is the number of resistance in series. For parallel combination, 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus dot dot. This is the formula which we need to keep in mind. Done? Is it okay? Can we move on? Is it okay? Hello? 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 Anyhow, let me.
Mine, sir.
Yeah. Just let me demonstrate one example. Let us suppose we have a question like this. You can imagine resistance as the bulb. Any electrical device, fan, bulb, your TV, your computer, anything. Let us suppose it's given that this is 20 volt, 2 ohm, 1 ohm, 4 ohm, and this is again 10 ohm. For the given circuit, find first equivalent resistance, second net current supplied by the battery, third.
Hello.
Yes, I'm just writing the question.
I
I have
can't
not
hear you.
said.
Now I can hear you.
I'm not writing. I'm not saying anything. I'm just writing the questions.
Okay, sir.
Net current supplied by the battery, current in each of the resistance, potential drop or potential difference across each of the resistance. Potential drop across each of the resistance, right? This is what we are going to find for the timing. We have all the other elements also, like what is the heat, what is the power, will come to know in the next session, right? But finish it out first. You have noted the question? Just if you complete, let me know.
Sir,
Yes, you're done.
sir, is this series or parallel, sir? Because first it looks like series and after that
No,
it
I'm
looks like
asking,
parallel.
I'm asking whether you have noted the question or not.
Question, yes, sir.
Yes,
I've
then
noted
we'll
it down.
discuss. We'll discuss. Now, I will ask question. You let me know what you do you think. That if I ask you, do you think that 4 and 1, these two are in series?
Sir?
Do you think that 4 ohm and 1 ohm are in series?
Yes, sir.
Yes, good, very good. Now, so if they are in series, can I sort out 4 plus 1 because we done the formula that R1 plus R2?
Yeah.
So instead of this 4 and 1, I can write only one resistance, that is 5 ohm, right? So the diagram will become this one, 2 ohm. I hope it is clear. No doubt till this point.
No, sir.
Now, the second statement which I will ask is whether do you think 5 ohm and the 10 ohm in the corresponding diagram, in this diagram, is in parallel or are in parallel? Do you think so?
5 ohm and 10 ohm, yeah, they are parallel, sir. Yes.
Yes, good. That means you got the logic right. So if they are in parallel, so instead of these two, what can I write? 1 by R equivalent is equal to 1 by 5 plus 1 by 10. That is 10 plus 5 upon 50, right? So that will be 15 upon 50. If the calculation is correct, I hope this is correct, right? So 3 upon 10. So R equivalent will become 10 upon 3. So instead of this 5 and 10, can I replace these two by only one resistance, that is 10 by 3, and this is my 2. Any doubt till this point?
No, sir.
Right. Now the third statement which I will ask, do you think whether this 2 ohm and 10 ohm 10 by 3 are in series? You think so?
Yeah.
Is it? Okay. So if it is in series, so can I
Yeah.
remove, instead of this 2 I can write 2 plus 10 by 3? That is how much? 3 into 2, 6 plus 16. So that will become 16 upon 3. So finally we are left with only one resistance,
Yeah.
that is 16 upon 3. So can I say this circuit, the above circuit, the original circuit was equivalent to 16 by 3 resistance connected in to 20 volt battery. Is it
Yeah.
okay?
Yeah.
Right. So your final answer for the equivalent resistance is 16 by 3 ohm. 16 by 3 ohm. Is it okay?
Okay.
No. Now, the second question was current supplied by the battery. Now look at this circuit. What is the total potential? 20. You know V is equal to IR. So there is no confusion because this is 20. Resistance is 16 by 3. So you are left with 20 into 3 upon 16. That is how much? 5 into
20 by 8.
5
15
by
upon.
5 4. 15 by I think 4. Is it correct?
Yeah.
Right. So this much of ampere. The second question is done. That is 15 by 4 ampere. Okay. Fine. I hope it is clear.
Yeah.
Now,
Sir?
current in each of the resistance. The third one is current in each of the resistance. So now let's come to the original circuit again. The original circuit was something like this, right? Something like this, 20 volt, and this was a 2, and this was, I think, over 5 and 10. This was somewhat 5 and 10. Okay, so we have done first two. I'm on the question number 3. In this we are asked to find
Yeah.
the current in each of the resistance. Now you said that 15 by 4 ampere of current was supplied by the battery. So the 15 by 4 will start from here, right? And there is only one way for the current to pass. So that means the total
Sir,
current.
actually, what's the question, sir?
Okay, okay. The question number 3 is this one: current in each of the resistance,
Okay, sorry.
right? You have noted the question or not? No?
I've drawn it, sir. I
Okay,
didn't
okay.
note it.
So just note down the fourth one also. Question भी note कर लो. Just note it down fourth one. Third, fourth. We'll discuss it.
Okay.
इकट्ठे कर लेंगे.
Okay.
Note it.
Yeah.
Okay. Now coming to the current, which we need to find. Now, whatever is the amount of current, that is 15 by 4 ampere, it was supplied by the battery. It will go like this till this point. It will find one resistance 2 ohm, but there is only one way for the current to pass. So the total current will pass through 2 ampere, 2 ohm. So I will say that. So what is the current through 2 ohm? That is again 15 by 4 ampere, because there is no other path for the current to flow, right? So till this point, the current will be 15 by 4. Do you agree?
Yeah.
Right. Now think, whenever you are stuck, think in terms of water flow or kuch nahi hai. It's same, right? Now after this we have two paths.
Okay.
So let's suppose this is I1 and this one is I2. So I can definitely say that 15 by 4 must be equal to I1 plus I2, because this is the two tributaries,
Yeah.
right? Now as you said that 5 and 10 in parallel. So if 5 and 10 in parallel, that means resistance through the 5 and the 10, sorry, potential through the 5 ohm and 10 ohm should be equal,
Yeah.
right? Since because they are in parallel. So what is the formula for the potential? Can I say I1 multiplied by 5 should be equal to I2 multiplied by 10? Is it?
Yes, sir.
Right. Now can I put this equation I1 is equal to I2 in the equation number 1? This is equation number 1. So this will become, if you place it here, this will become 15 by 4 is equal to 2I2 plus I2, right? So this will be 15 by 4 is equal to 3I2, which will give me I2 is equal to how much? 5 by 4.
Yeah.
Is it okay?
Yeah.
Agree?
Yes, sir.
Okay. So you got I by I2. So similarly, you can get I1 also, because you already told I1 is equal to 2I2. So that will be 10 by 4.
Yeah.
Okay. Now, can I say that current through the 10 ohm, that is I2, is 5 by 4? Can I say current through the this 2 ohm is 15 by 4? I got the resistance through each,
Yeah.
and I got the current through each one of the resistance in the circuit,
Yeah.
right? So this was our question number 3. Now if I
Yeah.
had asked you what is the current through this 1 ohm, what will be your answer?
Sir?
If I ask you in the original diagram, this one, original, the first one diagram, what is the current through this 1 ohm? What might have been your answer?
Um,
It's same
15
whatever
by
it
4.
was through 5, that is I1.
Mm, yeah.
I1 is 10 by 4. So ultimately 15 by 4 started from here. Till this point it was 15 by 4. In this 10 by 4 went. Here it is 5 by 4. Right. So you have got information about each one of the resistance. Right. Each one of the current passing through the each one of the resistance. Now the last part, potential difference across each of the resistance. Right. So therefore, whenever you know the current in any of the resistance and the value of resistance, you can definitely find out the potential difference across any one of the resistance. How? By multiplying I and R. So the potential difference across 2M will be 15 by 4, that is the current, into 2. Potential difference across 1 ohm will be 10 by 4 multiplied by 1. Potential difference across 4 ohm will be 10 by 4 multiplied by 4. Potential difference across 10 ohm will be 5 by 4 multiplied by 10. Any doubt?
No, sir.
Is it clear? Because this is important. Right. This is, this question actually tells you about 4 or 5 things. So it is important.
Okay, it's clear, sir. Can I just copy it?
Yeah, sure. Why not? Definitely. In fact, I will upload this, video in your account also. You can see it later on also. But note it down because, if you write it, you will get some confidence.
Okay. Then,
Noted?
yeah.
Can you move on?
Sir?
If you have noted, we can move to the next topic.
Yeah, finished, sir.
Yeah. Do you have any other class at 8:30 also?
No, sir, but I have tuition.
Okay, you have to go. And how you performed in your exam?
Yeah, good, sir.
Hmm? Okay. So whatever, just to give you the gist, I will leave you at 8:30. Don't worry. Just to give you that, we have finished what is current,
Okay, okay.
what is charge by time. I also told you Ne upon T. What is N? Number of charged particles. E is the electronic charge on electron. Right? So I'm just summarizing whatever I have done. Then I move to Ohm's law, which is important for competitive exam, graph type questions. I told you that V versus I graph. Slope gives you slope gives you
Yeah,
what? Resistance, right? That
yeah,
is represented by R. That is represented by R, right? So I can also say V by I is equal to R, and R is a constant, right? It is depending upon, what we say, geometrical factors, geometrical factors, right? Later on, we came to know about two types of conductors, that is ohmic and non-ohmic, right? So non-ohmic, ohmic means which follows V is directly proportional to I. That means for which V by I is constant, right? Non-ohmic, V is not directly proportional, right? V not directly proportional to R, right? Our example will be semiconductors. In this, we have semiconductors, and by the word semiconductor we mean germanium, silicon, and If you know periodic table, according to periodic table, it is group 14. You know periodic table,
Yes, sir.
right? So group 14 elements are semiconductors. Okay. Then we move to the formula, the numerical application, that is R is equal to rho L by A. Rho is called as resistivity. Resistivity, or it is also termed as a specific resistance. Important, right? Keep this point in mind. And this depends upon nature of the material. It does not depend upon external factors. Nature of material, right? Important. Next is, I today told you that if in the question it is given, if in the question is given identical metals or identical wires, it means same resistivity, right? Okay. Now we discussed the question related to, if length is doubled, if length is tripled, what is the percentage change in resistance? Percentage change in resistance, this type of question. Then I moved to the series combination today. Then we discussed parallel combination. These are important. You will find this
Yeah.
type of question in class 9th Olympiad or competition. If you appear for your state, Tamil Nadu State Olympiads, Tamil Nadu State Scholarship exam, do appear for the exam. You will get into, right? Then we discussed combination of series parallel. How to find current, finding out current. I told you a term called as potential difference. Although I have not elaborated it, we'll
Yeah.
discuss it later on in detail. Potential difference, EMF, voltage all mean the same thing. They all are volts. Units is volts. VOLTS represented by V. Battery, source, potential difference. Right. Then we talked about what is the equivalent resistance and net current passing through the any one of the resistance. Net current. So these are the gist which we have done today. Right. So when we'll move to the next lecture, we'll discuss heating effect of current, heating effect of current. After that, we'll talk about power, and this is the major part from where the competitive question of for your level will be asked. It is in class 12th also. This parts are in class 12th also, and questions are definitely asked. This is very much conceptual. We'll look after the unit. In fact, in UPS exam, this is asked. In this CDS exam Sunday, the paper was what is the unit of power, right? And the simple answer is what? Even a class 9th student know, right?
What?
Right. What is actually joules per second? I think you know this. Okay. We'll move to the heating effect, power, and combination. And by the word combination means what will happen if the bulb is connected in series, if the bulb is connected in parallel, which one we should prefer, and the metals of, or you can say with what element the electrical bulb wires are made of, or maybe heating wires are made up of. Some theoretical stuffs also. That is we'll discuss next time. We'll finish this thing in the next session. So just let me know. You can send me the
Okay.
invite for the class whenever you are free, right? So if your exam is over, you can have some
Okay.
frequent class because these days, I don't have classes these days because class 11, 12 exams are going on now. You might be aware of this board exams.